Hello everyone. Today we will talk about moment of inertia, a topic of rotational motion. Moment of inertia, if you want to calculate for a single particle, then you need to use the formula I means moment of inertia is equal to mr square, where m is the mass of particle, single particle we are talking about, and r is the distance of that particle from the axis of rotation, because we are talking about rotational motion here. So there should be an axis of rotation which is rotating in this direction or in opposite direction. Then moment of inertia will be calculated by I is equal to mr square. But what if we are having a system of particles? In case of system of particles, we are having a lot of particles here like this. So if the mass of this particle is m1, this is m2, m3, m4, so and so on. Distance of this particle is r1, distance of this is r2, this one is r3, this one is r4. From the axis of rotation, perpendicular distance we are talking about here, then I should be equal to sigma mi ri square, where I is equal to 1 from 1 to n. Or we can write it like this: m1 r1 square plus m2 r2 square plus m3 r3 square up to mn rn square. By this we can calculate the moment of inertia for system of particles. In case of rigid body which has a definite shape and definite mass, in this form, it can be a regular body or it can be an irregular body, but it is rigid. Then what will we take for moment of inertia? We will take integration, because we will take here a small part and integrate to it whole. Then integrate r square, a distance of a particle with a small mass. This should be taken as dm, a small mass, and integrate it with r square. Okay, now we are talking about first question. Our first question is: a ring of diameter 0.4 meter and mass 10 kg is rotating about its geometrical axis. Now we are having this single particle, a ring like this, a ring of diameter 0.4 meters, so that radius becomes 0.4 by 2, 0.2 meter, and mass of that particle is 10 kg. Mass of that ring is 10 kg, and that is rotating about its geometrical axis for 35 rotations per second. It will rotate 35 times in 1 second. It is the frequency here, but we don't have to use frequency in our formula, as I is equal to mr square. So moment of inertia becomes 0.2 square multiply 10, and the answer is 0.4, and SI unit is kilogram meter square. Second question: 3-point masses m1, m2 and m3 are situated at vertices of a equilateral triangle with sides A each, because sides of equilateral triangles are always equal. Now determine the moment of inertia of system about an axis passing through altitude of triangle passing through m1. This is m1 here. Now from here an altitude is passing, which divides the opposite side into equal halves, because it is an equilateral triangle. So this is our geometric axis about which rotation will takes place. Then I will become, because we are having 3 particles here, m1 r1 square, m2 r2 square plus m3 r3 square. So m1 is m1 here, and distance of m1 from this geometric axis is 0. m2, distance of this m2 from geometric axis is a by 2. As I told you earlier, you will have to take distance from geometric axis. Similar for m3. Now it becomes 0, m2 a square by 4, m3 a square by 4. Then our answer is a square by 4 m2 plus m3. This is our answer in kilogram meter square unit. Third question is sorry, calculate the moment of inertia with respect to rotational axis x dash in the following figures. We are having two figures here. So for the A figure, this is our geometric axis x dash, and this is our particle system. One particle we will have to take off 1 kg, which is having at position 20 centimeter, and second is of 4 kg, which is having position 70 centimeter, and this is geometric axis is present at 100 centimeter. Okay, then this distance will become 30 centimeter, and the distance of this from geometric axis become 80 centimeter. Now we will have to calculate moment of inertia. I is equal to m1 r1 square plus m2 r2 square, which is equal to 1 kg, distance is 80 by 100 square, plus 4 kg, distance is 30 by 100 square. Then it becomes equal to 6400 by 10,000 plus 4 times 900 by 10,000. 2 zeros, 2 zeros, 64 plus 36 by 100, which becomes equal to 1 kilogram meter square. B part is this diagram. Now our geometric axis is about horizontal system x dash, like ordinary x-axis system. Then here along y-axis you will have to place a mass 4 kg at 0,3 position, 2 kg particle at 0 minus 2 position, and 3 kg particle at 0 minus 4 position. Then your I becomes equal to m1 r1 square plus m2 r2 square plus m3 r3 square, which is equal to 4 3 square. Now 2 times minus 2 square plus 3 times minus 4 square. You can ignore these negative signs here because we are taking square here. Then 4 times 9, 2 times 4, 3 times 16, 36 plus 8 plus 48 becomes equal to 92 kg meter square.